Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate we know what the parent square root function looks like. However, it can be transformed. So let's briefly talk about what happens when it gets transformed. So this is the transformational form of a square root function. Let's quickly go through each part here. The a value is your vertical dilations, and it will reflect over the x-axis when it is negative. B is the horizontal dilation, and when it's negative, the graph will reflect over the y-axis. The C represents horizontal translations. When it says minus C, that means the C value is positive and it moves to the right. When it says x plus C, that means the C value is negative and it's actually moving to the left. The value at the end here is the vertical translation. You do exactly what it says. If it says plus the number, you move up. If it says minus the number, you move down. Let's practice applying our transformational form. First, let's list out the transformations we see. So inside here, I can see it's minus a number. So that means it's going to move to the right 2 units. And since it's plus outside, it's going to move up 1 unit. So to do this sketch, all you're going to do is start with the anchor point. Remember, the anchor point is the beginning point here that starts with the origin. We're going to start with the anchor point. We're going to move it to the right 2 units and then move up 1 unit. And then from there, the graph will just continue to increase. We're just doing a sketch. We're not doing a full graph of it. Now let's talk domain. What is the domain? The function actually starts at 2 now. So the domain is 2 to positive infinity. Let's look at range. The lowest this goes now is positive 1. So the range is going to be from 1 to positive infinity. Let's look at our intercepts. Well, our parent function had the origin, but based on my transformations here, this is no longer touching the x-axis, therefore it has neither intercept. Here's another example. First, let's itemize out the actual transformations. Now notice I gave you a negative this time, and since it's negative, if we go back to our transformational form, this means the graph is going to reflect over the x-axis. And see how it's plus 3 inside here? That means we're actually going to move to the left 3 units. So let's start with our anchor point. We know it starts at the origin, but we're going to move to the left 3 units. And that's it. So the anchor point stays here, but it's being reflected over the x-axis. So now normally the parent function would go in this direction like this, right? But that's not the case. It's being reflected over the x-axis. So our graph is actually going to go down here like this. So let's talk about our characteristics. What's the domain? Well, it starts at -3 and then goes to positive infinity. What's the range? Okay, well now it's switched. Before, it was always 0 to like a positive infinity or some number to a positive infinity because it was growing forever. Now this is decreasing. So this actually has an upper bound of 0 and it has a lower bound of negative infinity. Now let's talk intercepts. This does have an x-intercept. It's not the origin though, it's at -3, 0. And let's look at the y-intercept. Ooh, it does have a y-intercept, so we can actually solve it. Remember, with the y-intercept, you're going to plug 0 in, and then you're going to get out your answer. We can do our work over here. My y-intercept is -3. Don't worry about finding a decimal, just leave it like that.